By delay I mean a lot of delay. Like suppose, what the I mean, that is too much. So what is up guys, welcome to another Arduino advanced series, and this video is requested by one of my friends, and he wanted to know about a problem statement. Actually there was an Arduino competition which I luckily won, and he wanted to know the answer to the problem statement. Okay, so I must say, if I want to discuss the problem statement, it will take a whole lot of time, which you guys don't have. I mean, who watches longer videos than 15 minutes, isn't it? So I will try to make this video short and meanwhile discuss about turning points of that problem statement. Okay, so without just wasting time, let's get started. I have again opened this Tinkercad so that you guys can see it properly, and also it's not a mess using all those wires and actual hardware to build the setup physically. Okay, let's discuss about the problem statement. Okay, so the problem statement is something like you have to design a smart traffic light. Traffic light means you guys all know that it will turn red, yellow and green in a particular time span, isn't it? So what we have to design in here is we have this specific kind of hardwares like this ultrasonic distance sensor, Arduino Uno, and here are a couple of complementary components like LEDs. These are actually our traffic light LEDs. This is red. Actually I should turn this yellow, right? And this is green. So this is kind of our traffic light setup, isn't it? In the problem statement it's written that our red will light up for 5 seconds, the yellow will for 2 seconds, and the green, here comes the turning point, the green will depend on how much vehicle we have in our road. So it will basically vary with the change in the density of the vehicles present on the road. That means if we have larger number of cars or vehicles in the road, our green will turn on more, and if we have less cars, maybe there is no cars, then our green will not light up, something like that. So now you may ask how we can calculate the density of the vehicles present on the road. So that's why you are given this ultrasonic distance sensor. Basically what we are doing is we are just calculating a rough number of cars present in the road using this. And well, I can show you the code. Okay, so here you can see we have quite a few things going on. So here we have the calden, that means calculate the density. Well, if you guys have ever worked with Arduino distance sensor, which you guys may have because this is the Arduino advanced series anyways, so you guys know how to calculate distance using this distance sensor, isn't it? So basically that's the basic code of a distance sensor using ultrasonic sensor, isn't it? You guys also find that in the Arduino example sketch. So then we just have to use a counter variable which will count whenever it reaches a threshold. Like maybe let's say that if the distance is less than, what I've used, distance is less than 15 centimeters, right? So as you can see, 15 centimeters is pretty impractical, but as this is a prototype, so I've used a 15 centimeter, and whenever it senses a object which is less than 15 centimeters from the actual sensor, it will change the state to 1. Okay, and as the state changes to 1, it will count, the counter will increment by 1. So basically this is how it counts, and you have to call this function several times in your actual loop. Like see, here's the calden, and then you have to actually, how I have designed this code, that you have to calculate, I mean you have to call the function several times to find how many cars are present. And the program statement is introduced by such a way that when you are starting the simulation, you can see the serial monitor in here. So it will print the print the seconds in the serial monitor. Like, see, it is sensing 10 vehicles. As you can see in Tinkercad, you can select an object like this. So if we move the object farther away, as you can see 52 centimeters, it shouldn't count any vehicles, isn't it? As I put 15 centimeters in there. So see, it counted 1. As I maybe before counting, I put it in here. So let's see what happens. See, just stop up to the halt. I mean, it didn't count any vehicles, so it's quite accurate in here as simulator. So whatever, as you can see, I have to display everything in the serial monitor in 1 second delay. So that's why I put a lot of delay in there. As you can see, where did it go? So there we go. As you can see, delay of 1000 milliseconds, which is actually a lot of delay, but I have put it there. And you are obviously welcome if you can build this program using millis. Okay, so millis are always preferable rather than delay, because while you are using delay, it actually pauses the loop. The Arduino does nothing while it's in delay. So basically, millis are kind of efficient and delays are not, but delays are easy to use. You just have to write one line of code. So that's why I've used delay, because we have to use a lot of delay. Like here, there is a lot of delay, and as you can see, this is a loop. So every time the for loop runs, it will be a lot of delay. So that's how it works, and it's pretty simple, like lighting up LEDs for 5 seconds and display that in the serial monitor, isn't it? And there comes the turning point, which I am going to discuss today. Is whenever our system is running smoothly and suppose there is an emergency vehicles passing by, so we have to press this switch, and when pressing this switch, our green will light up for 5 seconds for the emergency vehicle to pass out, like in case of an ambulance or suppose a fire brigade or something like that. So how we can do that? And that is, guys, the turning point. I think in the whole code, this have 1000 points. If we can build it, we get 1000 points, otherwise we not. So how to design this? Now there's this several way you can do this again, like checking whether the button is pressed in the for loop in each of these loops, but that will kind of not work or fail rather, because we have used a lot of delay. Suppose you have pressed the button while your program is on delay, it will sense nothing. And that's why I've told before that using delays are quite bad and considered as bad programming, because you need to have millis, because while in millis it will perform as the same as delay, but the loop doesn't stop and the loop keeps running. Only these functions will not run, but the loop will run, and when you press a button, in that case it will detect the button press, and maybe I have another function, emergency, in the, where is that? Here, there you go, emergency, and that will call this button to glow. See, emergency, red low, yellow low, and green only high, and you have to wait 5 seconds in there. Okay, these are only the serial print commands. Ignore those, just this and these 3 lines. Whenever we press a button, our green will light up, see, and it will print green 5 seconds. That's case of emergency. Okay, so but as I have used delay, it will not work. So what should I do? And obviously using millis will increase the program size. This is a point to be noted, guys. When we are using delay, it is actually a single line function. It will not increase anything. I mean, you can use whatever you want in the delay, but when you are using millis, it will take quite a lot of space and lines. And here what we can do rather than millis is using an interrupt. Now what the heck is that? So interrupts is a function, and when, see, this is the function attach interrupt digital pin to interrupt 2 and then my ISR and falling. What the heck is that? This is quite a thing you have to understand, and that's why I've opened this Arduino reference. You can find this arduino.cc. Now you can see digital pins usable for interrupts. In Arduino Uno, Nano or Mini or other 328 based board, we have to use 2 or 3. So whatever, if you're using an Arduino Mega, then you can use this much of pins for interrupt. Now what the heck is the interrupt, isn't it? So as you can see, this is the syntax. Now these are, see, not recommended, recommended. So I will go for this. I've actually gone for this only. Attach interrupt digital pin to interrupt, then you have to assign the pin you want to use as your interrupt. Now then your ISR, this is your function which will be called if the pin interrupt detects this mode. Now what is mode? Now here you can see the modes. There are 4 modes: low, change, rising and falling. Now what the heck are these? Okay, now you have to see what happens when you press this button. In this particular configuration, I have attached this button from pin 2 to ground through a pull down resistor, and I have defined this pin 2 as our interrupt pin, as well as I have set this pin to input pull up. Now what the input pull up is does, you guys all have seen output, input, etc., but now I have used input pull up. Now what the heck is this? Input pull up means it will always be in 5 volts, and as soon as we press this button, it will be grounded through this 1 kilo ohm resistor. And I've used this 1 kilo ohm resistor to limit the current, because if you press this button, then inrush current will flow, which will short these 2 contacts, which will not be good obviously for your Arduino. Maybe it will be a fraction of seconds, but that is also not good for your Arduino. There will be a current spike, so I've limited the current using this resistor. So now whenever you pull this switch, this becomes 0. I mean, whenever you hit this switch, this 2 becomes 0, and other time it is 5 volts or 1 rather. So that's why I have used this falling. So now you guys may thinking, what is falling? I mean, you can see this is pretty straightforward. Everything is written in there. Change to trigger the interrupt whenever the pin is low, or changes to trigger the interrupt whenever the pin changes value. Rising means to trigger the pin when the pin goes low to high, and falling means when the pin goes high to low. Now I could be using low also and falling also, as my pin is always 1, and as soon as I press the switch, it falls. So that's why I have used this falling, as my pin is falling to 0, and whenever it is falling to 0, our interrupt is triggered, and this function is called, what is my ISR? Now see, this is my ISR, and this is actually kind of confusing because you cannot use delay functions using this interrupt function. Okay, so as you can see, I'm pressing this button and it is delaying for 5 seconds. It cannot be used directly through this interrupt, and that's why I have to make certain changes to do that. Like this is I'm flagging a variable to true, and then again another function which is checking if the flag is true or false. Okay, so if the flag is true, then the emergency function is called, otherwise it is not called. And as soon as the emergency function is called, the flag is again set to false. Okay, so this is quite confusing, and that's why I'm going to okay, where is that? I'm again going to create another program using the interrupt to show you what I'm talking about. So create a new circuit. Arduino. So Basically what I'm doing, again I'm going to set a switch, and our LED will be here connected to let's use the inbuilt LED rather. Our inbuilt LED is connected to pin 13 and this is our inbuilt LED. Okay, so let's tweak the code. So I'm again defining switch pin mode. Our switch is connected to 2 and that's why I'm defining 2 to input pull up. Okay, now this pin will always be in at high state. Okay, as soon as I press this switch it will become low, and as soon as again I release this switch it will become high. Okay, so now we have to define interrupt attach interrupt digital pin. Okay, I forgot the function because there is a lot of these case changes. See, pin is capital, I is capital, T is capital, so it's better to copy this thing, copy and paste it in here. I'm using 2 and then I have to select my function. Now let's call this function as test. Okay, and then again my triggering mode will be falling, as I've already told you that. Okay, yes, see, this I is capital, so better you copy paste it because and anyways I've not put a T in there, so paste. See, so again I have used falling mode because my pin is already high, and as soon as I hit this switch button will turn low. Now in our loop I'm not gonna do anything but only put delay. By delay I mean a lot of delay, like suppose, what the I mean, that is too much. Let's put a 10-second delay. Okay, now if we put a lot of delay then our loop is freezed and our loop is not running. Okay, but still I will be able to detect this switch press, and that is the work of the interrupt. Interrupt has always the highest priority. Now let's write my function void test, and I will just light up the LED, or blink it rather. Digital write 13, that is our inbuilt LED, high. Remember, we cannot use delay in here. Okay, we cannot use delay inside of that function which you are calling through our interrupt. Okay, so we cannot delay in here. So let's run this code. What happened?
Hey, what happened?
Void test digital write is not declared in this code. What the f is that, dude? Digital write. Holy sh! See, I keep on making silly mistakes, dude. There we go.
Nice.
Now see, our circuit is on, and as soon as I hit this button, our LED lights up. Can you see it? Oh my sh! The LED is very dim, dude. I should have worked on it. So as you can see, our LED lights up, and now I can use this in here. So the LED digital right 13 becomes low. Okay, So our delay is here, but still we could use, still we can detect our button press and light up this LED. Isn't that cool? And as soon as the 10 seconds are over, our LED turns low, isn't it? See, 10 seconds is over. Now I have switched again to our 10 seconds is keep on counting, and again as the delay gets over and our LED turns off, which makes sense, isn't it? It's kind of cool, and this is the turning point, and you have to work on this interrupt because this is very useful, and this is also a building block of your advanced knowledge about Arduino. So hope you guys enjoyed this video, and if you need the actual code, then I can give you that. Let me know in the comments below. And also, as I've told you that we cannot use delay in here, so I have to use a different kind of approach to get that delay of 5 seconds as I wanted. Okay, and as I've already showed you that I have called a function myISR and flagged a variable to true and checked that variable to be true in my loop. See, here I have char that is checking it. Here I have another char. So after 1 second of delay, every time I have checked this, call this function. What this function does is check whether my flag is true or false. If it is true, then that basically means we have a button press, and that basically calls the emergency function. And now as I have came to this emergency through another function, we can use the 5 second delay. So that's how it works. It's pretty simple if you understand it, isn't it? Just let me know in the comments below if you want this original code. I don't know if this code is the only one which could be there for this kind of circuits, but this is quite good. As you can see, as soon as I press the button, the green lights up. What the f? Oh yeah, there we go. I've hit here, not in the button, because whenever you hit in button, it will obvious that it will trigger it because we are using interrupt. So that's all for today. Hope you guys enjoyed the video. If you did, give it a thumbs up. Don't forget to share and subscribe, and also if you want, then you can support me on Patreon to keep the show going. So that's all for today. This is Malhar. You are watching Outta Syllabus, and I am signing off.